Hi everyone. Today we're going to study differentiation of power series. Let f of x equals summation from n equals 0 up to infinity of a sub n times x raised to n. We can expand this into a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus a sub 3 times x cubed plus and so on, such that the absolute value of x is less than capital R. This is the interval of convergence. Then, for absolute value of x is less than R, the function f of x equals the summation from n equals 0 up to infinity of a sub n times x raised to n is continuous and can be differentiated term by term within the interval of convergence. The derivative of power series, this is the notation f prime of x. We can show that we're going to take the derivative of each of these terms. So we have derivative or d over dx of a sub 0 plus d over dx of a sub 1 times x plus d over dx of a sub 2 times x squared plus and so on. And the answer will be in here. Derivative of a sub 0 is 0. A sub 0 here is a constant. Then derivative of a sub 1 times x. The answer is a sub 1 plus derivative of a sub 2 times x squared. The answer is a sub 2 times x plus we can write the next term here. That will be a sub 3 times x squared. Then we can write the new series into summation from n equals 1 up to infinity of n times a sub n times x raised to n minus 1. Let us see example 1. Differentiate term by term the power series summation from n equals 0 up to infinity of the quantity x plus 5 is raised to n. Let us expand the series and we will write like this. The x plus 5 is raised to power 0 plus the quantity x plus 5 is raised to 1 plus the quantity x plus 5 is raised to 2 plus and so on. We can simplify this further. This x plus 5 raised to 0 is equal to 1 plus this term here we can remove the exponent 1 plus then we copy the remaining terms. Now differentiating the series, we can show that the d over dx of this sigma notation, and we will show that this is derivative of this term 1 plus derivative of the x plus 5 plus derivative of the square of x plus 5 plus and so on. Evaluating this now, we have this 0 plus 1 plus 2 times the quantity x plus 5 plus and so on. And we can write the new series into summation from n equals 1 up to infinity of n times the quantity x plus 5, and that is raised to n minus 1. This is the final answer. Example 2. Find the derivatives of the power series for e raised to x, given by e raised to x equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x raised to 4 over 4 factorial plus and so on. Now let us differentiate the e raised to x. That is the d over dx of e raised to x. Let us take the derivative of each of these terms. So derivative of 1 is 0 plus derivative of x is 1 plus derivative of x squared over 2 factorial will be 2 times x over 2 factorial plus derivative of x cubed over 3 factorial is now 3 times x squared over 3 factorial plus derivative of x raised to 4 over 4 factorial is now 4 times x cubed over 4 factorial plus and so on. We can show here that we can expand the factorials and it will be like this. We can simplify this further by cancellation of these 2 and these 2 in the denominator. This 3 and the number 3 in the denominator, and this number 4 and the 4 in the denominator respectively. And the new answer will be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on, following the same pattern. We can see that these terms are the same as above. So we can write e raised to x. Remember that the d over dx or the derivative of e raised to x is the same e raised to x. This is now the final answer. I hope you learned something from this video. See you again next time.